What is a sampling distribution again? Okay, so let's talk about that. Sampling distributions show the likelihood of obtaining a value of some statistic given n observations. So if we were to ask the question as we left off last time, what is the probability of getting a mean of 4 with 3 observations? That we would look at the sampling distribution, and this would tell us the probability of that. How do we construct sampling distributions? Well, you have to choose a sample size. Every sampling distribution is based on some sample size. We randomly select all possible combinations of n-scores, we compute the statistic of interest, and we plot the relative frequencies of the values of the statistics computed. Now, we did this already with the de Moivre demonstration in Excel, and that is what we computed was proportion. We computed the proportion of heads, which is a statistic, and then we plotted the relative frequency of those proportions, or the proportions of those proportions, and got our sampling distribution. Now, the problem with sampling distributions or constructing them is even with a small population, for example, of 10 scores, and even a small n, an n of 3, for example, there are 10 to the 3 combinations, or 1,000 possible independent random samples. So, to construct a sampling distribution is very, very difficult to do it on your own, by hand, without a computer, or without some super way. So, for example, let's construct a sampling distribution. I'll show you the problem with this with using the smoking study. And that is, I have the data here of ID number and cigarettes per day. In a sense, Tim Baker asked, how many cigarettes do you smoke per day? How many, each one of the participants in the smoking study were asked that question. This means that the person who was ID 2001 smoked 20 cigarettes per day, 16 cigarettes per day, 12 cigarettes per day, 30 cigarettes per day. These are different people. A person number 2005 said they smoked 25 cigarettes per day. Person 2011 said that they smoked 20 cigarettes per day, etc., etc. If we were to construct a sampling distribution of these data, we might want to start by constructing a relative frequency distribution. Okay, so there were 19 people that said that they smoked between 1 and 10 cigarettes per day, 146 that said that they smoked between 11 and 20, and so on and so forth. And here are the frequencies, here are the relative frequencies of how many cigarettes do you smoke per day. If I take that frequency distribution and that relative frequency distribution, I can construct this. This is a graph. This is the relative frequency distribution of sig day. It's positive, it has positive skew, it's unimodal, it's asymmetric. Okay? You can see that its mode is 20, its median is 20, its mean is 22.4. It has a range of 95, it has a variance of 97.33, and a standard deviation of 9.87. This is the probability distribution of scores. And we just did it by counting and then dividing by the number and calculating the mean of that, calculating variance. We did it in Excel, var.s, standdiv.s, calculated. We all know how to do that. Okay. Now to construct a sampling distribution from this group of scores, we have all 608 scores. And let's say we want to construct a sampling distribution around an n of 10. What that means is we randomly select 10 scores and we calculate some statistic. Let's calculate the mean. We sum up the scores, we divide it by n. We get a mean of 22.7. That means that a single sample taken from all 608 scores gave us a mean of 22.7. Now, if we throw those scores back in and take a new random sample, we get a different mean, 30.8. Well, that makes sense. I mean, sometimes we're going to get some higher scores, sometimes you're going to get a lower scores. Remember, we're selecting 10 randomly out of 608. We're not always going to get a mean exactly the same. They're going to be different from sample to sample. If we do this over and over and over again until every possible combination has been selected, we'll be here all day, all year, all our lifetime. There's this many possible combinations of 10 scores selected from 608, believe it or not. Okay, so what do we do? What if we do it 100 times? Let's just start with 100 and see if there's a pattern. If we do it 100 times, this is the relative frequencies of the of a particular mean of the sig day. If we do it 1,000 times, this is what we get. If we do it an infinite number of times, or a large number of times, and it's probably not an infinite, we wind up with this. Does this distribution look similar, familiar? Yes, it's a normal distribution. In fact, it's de Moivre's theorem that saves us. De Moivre's theorem says that if we do an experiment over and over and over again, we will wind up with a normal distribution of outcomes. This is a sampling distribution of sample means.